changed the higher speed belt here on the lathe, and I got it in low gear here. It's just cutting. I didn't like the way it was cutting. Yeah, well, that's my belt is just slipping. I need to. Something's going on. Okay, I see. I'll fix that. Well, this is a high gear and medium high speed. I don't know what this is. I got a chart up here. High gear. I would say it's probably about 1,000 RPM. I'm making the cut less here. For some reason I've got it. Oh man, I'm screwing up. Instead of feeding it forward, I was pulling it back instead of moving it this way. Let me find my zero again. Back out so it hits, and then we'll go forward. Yeah, that's cutting at a pretty good speed. You can see my hands moving. Oh, I got a hot chip down my neck. It's making long, curly chips, so this is about as fast as we're going to be able to cut this stuff. A lot of times, let's try 25 thousandths. That's 50 thousandths altogether. You can see in there it's cut nice and smooth. I'll have a nice hole whenever I'm done here. Okay, these calipers are locked at the size I need. As you can see, I'm very close here. So now I'll be taking very small cuts. I'm actually going to measure this. It's supposed to be 630. Let me unlock this. And this is showing me about 570. So I got 50 thousandths. That's plenty of room to start getting it close and then test fitting a part in it. So what I'll do, just for demonstration here, I'm going to take 20 thousandths here. Let's see. Let me go in and touch off. Anyway, I'm going to take like a 10 thousandths cut across there, and let me set up to do that. Okay, we're cutting about 10 thousandths. I'll try to do this as smooth as I can with one hand. You can see the cutting surface in there. And I'm just moving it like this. But it's taking a nice cut. It's going to be good enough for what I want. If I was using two hands, I could make it a lot more smooth. But for now, this is good. The same cutting, I'll just run it through again. You can see in there it's making it smoother. So now I'll measure this and we'll start going for thousandths, and then I'll try to get a really smooth cut. Alright, I took a 10 thousandths pass that time. And there's the diameter, and it says 600, and I think I need 615. Let me check this again real quick here. Of course, one-handed is never as good as two. Yeah, I got 620, so it should be about 10 thousandths, 20 thousandths total for this part to go in here. I'm going to start checking it and see what happens. Okay, here's where it needs to be, and it's just barely started there. So I'm just going to be taking like 5 thousandths at a time for a couple passes. Belt slipping. Okay, I'll just take 10 thousandths here. See, that's taking a pretty fine chip out of it. I'm going to put the camera down so I can do a smooth cut. Okay, there we go. This fits in here. Smooth enough, it's snug enough. I did it overbore it just a tad, but I actually bored it for this one, this end. Yeah, but anyway, it's tight enough, especially when I put a couple holding screws. I'll have to drill this and thread it so I can get something to grab that. Let me see what this looks like in the chuck. Let's see, that should go up in there. Again, this is sort of hard doing it one-handed backwards. Switch camera hands. Yeah, I don't have a lot there, but see, I do have enough to clamp it. I just clamp it real loosely here. Fire this in. See, it's running out of center, but that's all right. I can bump that around with a dial indicator and set it perfect. Plus, nothing in here is really bolted down. See, it's just moving around. It's loose. So now I'll drill this and thread it so I can clamp that part in there, and then I'll have me call it. Alright, we got it bored out and a lock nut tapped and threaded. It's holding it. You can see it's out around right now quite a bit, but I haven't really got it clamped down or anything. I'm going to straighten it up with a dial indicator and get it all squared, and then we'll try to bore it. Alright, I've got it indicated here. It's jumping about, well, there's 0, about 50 thousandths out. Clockwise is a high side, so here would be the high side, and I'll just take a little rubber hammer here. Again, this is one-handed without the camera, and I'm going to just tap this in. You can see I've tapped it in about 20 thousandths or so. And I spin it again. Yeah, see, we're within 15. I take to the high side, and just a little tapping on that far corner there, and spin it once more. There's a high side right there, right on that jaw. Let me take this thing here off so I can at least swing my hammer. Okay, there's 80, 70. Okay, so take it to the high side, 70. A little tap. Okay. Now we're at 50 right there. Just a tiny hit. Alright, so it's within 2 or 3 thousandths right now. The outside I don't particularly care about. What I need to do is check this inside one, because that's the one that's going to get bored. What I need to do is make a ring of this size right here and hold it so that this is completely straight with the inside. That really can't be when I've only got one screw in it holding it down. See, now indicating off the actual part I'm supposed to bore. I got about 15 thousandths. So what I'm going to do is just bring this tailstock up, because this thing is centered, and run it into that hole there, and that should make the hole center. Make the indicator off here, and run this tailstock up here. Yeah, see, that'll do it. Where's lost my wrench. Let me find my wrench, and I should have, here's something. This will work. I'll just tighten this clamp down here real quick. There we go. And I'll use this to screw it in. And even if I turn it on, guess it might help if I put it in some kind of a gear. Well, let's try medium again. Yeah, see, now this will make it run true, or more true. I can still put my dial indicator on it, see what's happening, but I can see it's much truer than it was. I'll just do a little tapping on it, pulling around, and try to get it more close. Okay, I've got a much more accurate setup here. Let me just set this one at 0. Alright. So this is, these are a much smaller gauge, so there's 5, 10, 40, 0, 6. I don't know. I don't have my right glasses on here. Oh, it's a 10. So we're going 5, 10, 15, 20, about 25 thousandths. So we'll do the same procedure. I'm going to tighten this screw up here quite a bit better, and before I really finish doing that. I think this is the right one. Yeah. Give that another half a turn. What did we do? Oh yeah, see, I pushed it over on the side of the screw. Just pull it back until we're touching here. Okay, there it's not touching. Pull it in until it just starts. Yeah, so we have to move this quite a bit now. So now that I'm on the other side, what to do with my rubber hammer? Everything is backwards, but I can pick on this. See, that's taken out 5 thousandths at a time, and spin it. Whoa, I made it worse. So it looks like this is the high side, so I want to go opposite. Means I want to hit it back here in the back. I don't know where I'm at now. Anyway, that's all I got to do is just keep playing with this until I can get it centered again. I'll try to reset it with the tailstock now. Alright, this is 0.5 thousandths indicator. You can see it's and I'm within say that's a 5. I'm probably within 2 or 3 thousandths, 5 thousandths, which is plenty good for what I'm going to do. Let's try to run it to speed. Yeah, see, it's running pretty good on the outside, and the inside looks good. And I've got it in the chuck real good and tight. So I think this will be good enough to start boring it to the size I need, which is 3/4 the size of this shaft right here. And next we start boring. I swapped it out for a carbide bit. I'm just feeding it in by hand here. Here it cut. So we can look at how much you cut in there and see that oh, there's a big place where there's no teeth at all. How about that? Anyway, so it's boring. I'll just do a little more setup here. I may change that bar. I think that insert's bad. I think I'll use a little different boring bar. See if we can get it cut smoother. I played around with bits and stuff here. This one's cutting pretty good, but it gets into where it's threaded. Pretty rough, but I've got it going through. I think this is, yeah, that's it. I'm not taking very much out of it at all. That's pretty hard steel. Yeah, it's just not cutting very well. I still don't have my, I can see the bit actually moving. I need a slicker setup and probably a carbide tool. I'll try something else. Now this is a much stronger setup. Same kind of braze tool. Yeah, it's making nice chips. Still got some chatter in it, but it's got those splines inside. Take this and use 2 hands on it so I get a smoother feed with this interrupted cut. Alright, I got a decent test hole at this point. I'm past the threads, it's running smooth. I've got 640. The shaft needs to be 750 something. 750 exactly. So 640. I got another 40 thousandths. I got about another 100 thousandths to take out of this. So I'll get close to it and then I'll creep up. I'll show you. Now it's past all that interrupted stuff. I'm just going to dial in 10 here. So that's 10 thousandths total. See, it's cutting it real nice and smooth. Nice chips. I don't have to be very smooth with it. See, now I give it another 10. There's 20. That's a better cut. I took 20 and then 10, that's 30, 60. I should have at least another 40 thousandths to go. And I'm just moving this back and forth, keeping it nice and clean. So I don't put a lot of tool pressure on it because I don't really have it. This is not really a super stable thing, and I've only got just one tooth of my jaws on it. So we'll measure it. Supposed to be 750, and we got 660. We've got 40 thousandths to go just to get. We got still about 90 thousand. So it's going to take several passes, probably 7 or 8 passes through here to get it to the right size. All right, we're a couple thousandths. There's the actual shaft that was in the drive down here before, just 3/4, and it starts, but it's not really going, and I can see a little rough in there. So what I'm going to do is I'll just use a cross slide here. I'll take another maybe 3 or 4 thousandths out of it. Let's see what this sounds like. Yeah, that's probably about 3 thousandths. Making nice little chips in there. Just realized you're probably just looking at my tool post. Just clean that up. See if our shaft wants to fit. Yeah, see, well, that's even a little sloppier than I want it. See, I'm glad I didn't go all the way through. So I went too far with this. This is a slop. Let me go in another thousandths and then tighten it. And yeah, I can hear it touching there. So now I'm probably taking a couple thousandths out. It's a smaller cut. A couple thousandths won't make any difference on this shaft down here, but I do want it to fit real tight so it's, you know, not wiggling around and close to the center as I can get it. I think that's plenty big right now. Yeah, that's good. See, it's not as tight as I would have liked it, but if I put 3 screws in it instead of just 1, or 3, you know, clamp screws. See, I cut that bigger than I wanted, but that's the way it goes. Anyway, so I'm going to clean this up and get all the shavings out of it. I don't want to dismount it from the lathe. Now, right now at this point, I can take the lathe and start facing this, and I can take off like 1/4 of an inch of it if I want. But I don't think it's going to be this part that's actually hitting down here. I think it's going to be the shoulder part. So I can always cut this thing off if it's not working out. So actually, I think right now I could probably pull this out and we can check it and see if it fits the screw. Alright, yeah, it fits on there really nice. It's got a little bit of play in it. I think that's about as far as we can get it right now. I'll put a set screw in it and see what we got in the way of lining up. It'd be easy enough to put a shaft in here. Well, here's our next little test. There it is, mounted basically exactly where it's going to go. Let me see if I can feed this carriage in. Oh man, nothing bolted down here, and looks like I'm 1/2 inch off, so I'm probably either going to have to trim this a little, 1/4 of an inch. It's not going to help much. and I can just hold the feed screw up right now and slide the carriage. Well, that's fine. It's hitting right on the edge here. I can actually move this back. I can push the feed screw in. So we're hitting right here, which is really not bad at all. This feed screw is not really, it's hitting the lock screw right now, but that's actually not bad. See, I'm still an inch away from my, let me see if I can get this set up again. Alright, with this now setting right with the feed screw, I'm only maybe 1 inch away, and I do have enough, I can't get that off there right now, maybe. Yeah, I have to loosen this up. I can get it off this way. There we go. But I can still run this carriage here in. Okay, that's the maximum on it. So I'm within 1/2 inch of the content in the chuck here. So I haven't messed myself up too bad at all. And these with these nice U-joints in it ought to make a big difference in the constant speed of this thing. Next course is to cut my shaft, that piece that I was making for the transmission. I don't know what I did with it, but I have to make the correct joint to fit in here, put the gears all back together in the transmission, do some measuring here, see how much I need to cut the shaft so that the bearing here will fit on the end and hold, and at that point I should be good to go. Yeah, I found one of my wrenches. So anyway, I was kind of glad about where it hits. If I really get down to it, I could machine 1/4 of an inch off of that end, but this one here is going to be, I may just do that to start with, because I can re-drill this over here and put a different lock nut on it, or move this one over, you see. So 1/4 of an inch is 1/4 of an inch. It'll make the whole lathe just that much more strong. But anyway, it looks a lot better than the old one. It's massive, but it's made to transfer a lot of power from a 3/4 inch shaft. And actually, when it's all geared down, it does have a lot of power. So it should make everything with these ball bearings in here much smoother than that old one. Plus, these are machined directly parallel, and I had to I'm sorry, I wasn't watching where the camera's going. These were machined directly parallel, and I cut the other one and put it together, and not only I probably didn't get it straight this way, I probably didn't get these two bearings exactly aligned, and that would make it go fast and slow. So here, this is about the best we can do. Ideal, there's maximum is 45 degrees, so it looks like I got about 30 there, I'm getting close to the maximum that this U-joint is recommended, but I think this will solve all my problems. Well, I'm moving along here on, this is a shaft. It's got two flats on it here, you can see. So I put the vise back on. What I'm doing now is trying to make sure that it's square, and I'm going to do that by, I've mounted a solid piece of steel in here, and I'm going to take the square up against the level here. Kind of a two-handed job. It's got to go down, start with. This needs to be cleaned off here, and put my square in here, and see, there we go. And I ran it up there. I don't believe that. This is boy, can't get much better than that just by pure accident. It looks like I just mounted this in here square just by completely by accident. Well, good. I can just tighten it all down now and I'll be done. Okay, I got this all mounted up. All looks good. I made a mark on the thing there. So that's how wide the flat has to be. We'll just bring it up until it touches. We'll call that 0, and then we'll measure how big it is. The flat here, of course, back to my one-handed crippledness, is 540. So we got 540, and this is, should be 3/4. Yeah, 750. 540 from 750, we divide it by half, and that's how much we go up. Well, I accurately measured this, the two parts, and it looks like I need 100 thousandths per side. I'm just going to bring this up until it touches. Call that a 0. Yep, cut off a little, so I just need to take this in 100 thousandths. I don't know if you can see down in there. So I got 55 roughly. I'm going to just take a 10 thousandths pass and see what happens. Take a while to get over there. This will be 10 thousandths. Yeah, it looks pretty good. So I just got to go 100 thousandths, 10 more passes like that, and I can flip over and do the other side. According to the scale on the lathe, that should be 95 thousandths. I'm going to just check this for dimension here. So 750. I still have 665. I need to go another 10 thousandths, so I'm going to dial in 7 and see what happens here. Well, just take another 7 down there. There's 5, 6, 7. And put a little oil on it. Hit our power feed. Let's see what happens. 7 to, whoops, I'm on the wrong side of the cut. So I'm at 52. I'm going to lower it, go back, bring it back up to 30, 40, 52. Gauge the power. Alright, I'll measure it again. And so it looks like about 58. I still got to take another 8 thousandths. We'll go back. Now put another 8 thousandths in it. Be right on 60. Gauge your power feed. Put some oil on it. Alright, that should be right at 650. I'm going to roll it out here. Check it. You can see there it's about 652, something like that. I'm going to take another 2 thousandths. A couple thousandths. Actually, I might just take not put any more in it. We call it a spring pass. It's just another pass at the same depth. To take the pressure out of the tool. And it sounds about right. I'll just check this once more. Yeah, see, I've got 746 here now. 750. Yeah. So that's good for that side. That's 100 thousandths. Now I'll just flip this over, take 100 thousandths out of the other side. The reason that I've got this in this block is so I can turn it over and have a flat exactly 180 degrees from here. I don't know what's going to happen with this, but I'll try to set it up right here. Now I got a little problem. The cutter's going to interfere with the vise right here, and I'm all the way up against the stop here. So what I have to do is loosen up this vise, and let's see if I can do this without one-handed. I'm just going to give this a quick loosen. And the whole vise has got to come back my way. So we'll see if we can do that. Yes. See, it's come back. I want to I've kind of knocked the mounts loose here because I'm trying to do it with one hand. Anyway, I got to move the vise back and then square it up with the machine again, and then we'll continue with this. Yeah, it's all mounted in square again. You can see here that I'm just about to touch. I'll bring it to the middle. Turn on the cutter. I raise this up here with this thing. Oops, wrong way. So what I'm going to do is just raise this up until it just touches. That wasn't on center, but looks like I might have took 2/1000ths off, so now I gotta go to 100/1000ths. I'm close, so I'm gonna measure this. It looks like I'm about 755. I'm going to take another 5/1000ths here, and we'll make a power pass across this, and that should be just about finish up our milling. Next thing I'll be try to see if the joint will fit onto the shaft. Alright, we'll just crank her on out here and measure it. I haven't really cleaned it off or anything, but yeah, see, it was 755, but I probably got 5/1000ths worth of junk on it. We'll just see if the part will fit it. If not, we'll massage this a little more. Did a little measuring and checking, and yep, fits on there perfectly. I've got like 1 or 2 degrees at the most, so I can tell by the wiggling that that's probably within a couple thousandths of where I want it to be. Anyway, that's good enough to run this thing pretty straight. Now I can take all this out of the lathe or out of the milling machine and get back to work on putting that shaft that I just worked on back here into the gearbox and kind of make some final adjustments and so forth. More out of curiosity than anything, but here's the check. I've got this dial indicator in here. Right there is the 0. It's on the lowest part. I'm going to turn this around here. I have to do this two-handed. And we're going to move this now until it's the lowest. It's 80. So it looks like I've got 20/1000ths difference between the two sides. Yep. Not sure which one is actually off. Looking at that one, looking at this one looks like it might be a little too big. So I can check this with Couple of ways of doing it. This is the easiest way. I'll just check the depth here with this thing, and it says I just knocked it off, and it says 190. See, this one's about 10 thousandths low, and this one, that was probably me and my measurement, and this one says 95. So I've got 10 thousandths off. This one needs to be turned a little. I'm sitting here looking at it and I can see that it's not perfectly parallel. So probably what happened whenever I was machining this is that little weak clamp in the vise made the end go down, and this one the end didn't go down. Anyway, 10 thousandths, it still fits, don't care. But if we're curious, I've see how I've got the thing right up against the edge there, so it looks like it shows about 5 thousandths, and you see as I move it towards the end, see it's off 7 thousandths there. If we check the other side, that's 80. See, we don't have any. 81, 80, so I'm 1 thousandths off on this side. This was the second side I cut. This side is tapered about 5 thousandths, just in this 1 inch or so here. Anyway, that's because of this funky setup here. The part stuck out so far to get to the cutter and so forth that just the pressure of several passes moved it. I should have checked it, but I'll remember now in the future when I have stuff like that to make sure that I do check the security of the vise. Here's our transmission after drying. Looks really good. The gears turn well. Of course, it's not really lubricated or anything here. I'll put some gear oil on it, but it definitely got rid of all of the grease and metal chips and so forth. Now I'll just lubricate this all up and put my shifter handles there back in it. And first thing is this the shaft that we just machined. We'll clean this up real good and oil it and put the shaft in it. Here's the shaft end. Turns pretty free. I've got a tight spot here, and there's a nice easy spot. Anyway, I don't know, it could be anything from tiny pieces of dirt in there to perhaps the gears are not perfect themselves, or the bushing is worn crooked. Could be anything. So I just tighten it up to where it'll turn pretty easily, and Loctited that nut here on there so it won't go anywhere. Everything looks pretty good. Now I put in my shifting levers and finish oiling this up. And there we go. It's on and mounted. Here's the cheapo one that I had before. Well, not so cheap, but I'm trying to get you a comparison there. You know, I lost about a ½ an inch on the length, and I go over here to this. That's in all the way. I don't know if you probably can't see on this camera, but I need about 1/4 of an inch. So I got to take 1/4 of an inch off of this shaft right here, which that shouldn't be any kind of problem. And then I can get the rear mounted. See, it's causing quite a bit of movement and stuff. So once I get the rear mounted, then I can find out how this is actually interfering with the carriage and stuff here. So that's the next thing, is to cut some of that shaft off. Next thing, my short screws that go in here to lock this down are way too long. So what I've done is chuck one up here in the lathe, and I'm just going to start turning it down. That's about 2 threads past the end of that. I'll have to be careful with it because I hardly got anything that I'm holding it with there, but this should be able to trim it down to the right size. There we go. Looks and sounds good. Running straight. I'm going to engage it here. Looks like it's going nice and smooth. Won't hear anything at all in the... Got a little ticking coming out of here. Probably a gear, but when I press on it here and load it, something off. I'm not sure what exactly. Looks like it's moving the shaft here in the end of my holder. So I'll retighten all of this up and see what happens. But it looks good. That was this end here. I need to do a better bearing. But I'm just going to try to do a pass here. That's a pretty high feed rate. Looks good. Having a medium-high range, I'm going to go to the slowest speed and see what. There's low range, and the last low. That's as slow as it'll go. Cutting pretty smooth. I can hear the motor pulling down. I'm not sure exactly what's causing that, but if I look at the lathe wheel here, it's traveling very well, and I don't see the pattern in the shaft. It looks like it's cutting much better than it was. Now I'm going to go back here and take about 3,000. Yeah, you can see that's cutting real nice there. Got some kind of a little harmonic in it, but it'll get better as we go along. I really haven't set these up perfectly yet. did have a little bit of drag in it. So we just continue to make things more solid and see what happens. Now here's a slow pass with a better tool mount. It's in quite a bit stronger. As you can see, it's pulling off nice little tiny chips. And this metal is hard to cut. Shiny. Plus I haven't even checked my tool height. You know, this cutter could be a little too low or too high or something. But the main thing that I'm looking for is that I have this isn't going to focus. So I have a nice, smooth, even cut. I can hear a little about half a turn. Started. Can't even hear it hardly anymore. Going away. I think that was probably part of this in the gears. This box is still, you can hear as I pull on it, it's still not knotted down real tight. So, but anyway, this is cutting real nice. It's coming up on a bigger piece here. Yeah, that's probably cutting 10 or 15 thousandths. Cutting it very nicely. I can tell it's so much better than it was before. I can just look at the wheel here and see how evenly it moves. And of course I can see up there in the cutter how well it's doing. So anyway, looks like my huge double U-joint here was a success. Now I just do some more working, mounting things and adjusting the gears and so forth. And that'll be it for this last piece of the project. What I've done here is just put a dial indicator here against the shaft and turn it on. I've got a little, interferes just a little right there with that screw, but you can see it's at 10, 20, 40 thousandths. I'll try to stop it on the high side here. That's 40. Alright, so this side here, 40 thousandths too much towards me. I don't know how much of that. Let's see what's happening on the low side. There's the low side. So this side needs to come towards me just a little bit. And the high side is right in here. Okay, so what's happening is this screw, as it tightens it up, is probably moving that moving the collar towards me a few thousandths. So what I can do is put a little spacer or a little thin piece of something back in the back there, maybe a piece of tin foil or something to force the shaft this way, and see if that works any better. Well, what I've done is cut a little piece of shim stock here. It's about 5 thousandths, and I'm out 40 thousandths, so this should hopefully change it to about 30 thousandths if I can get this in. I know I machined that awfully tight fit, but perhaps because of the threads it might go in. What I did here, I couldn't get the shim in it because it fits too tight, but what I did do is just turn it around 180 degrees. Before, the high was right here where the pin is, and now if you look, we're watching the screw there. See, 50 thousandths at the screw, and 180 degrees away from the screw, 0. So it's still running within 50 thousandths. I'd like to get it to run a little straighter than that. Maybe I'll try some tin foil or something. Gotta be some way of holding that shaft over 10-15 thousandths. Alright, I'm within about 30 thousandths. I managed to get one little tiny shim in there. It's not even opposite to where I wanted it to go. Looks like I'm off a few degrees, but anyway, now the bushing is running a little hole right there, and we're running about 30 thousandths. So it's better than it was. I don't think 30 thousandths is going to do much. Let me go up here and I'm going to put this thing under some load. Well, I'm interfering down here. But might be able to take a little off right here before I hit my thing. Let's see which way I got this. It's moving so slow it's hard to tell. Yeah, it's moving the right way. It'll be cutting, so I'm going to give it a couple thousandths here. Now we're pulling 30 thousandths still under light load. Got a little hole there, 10 thousandths, but basically 30 thousandths. About to interfere here with my thing, so 30 thousandths, that's not bad. Let's get a higher speed and see what happens. Faster speed, you can really see it. Got 0 here at the end. Yeah, see, it's still running 40 thousandths out. And try to just set it on the high point. Well, there's a low point. It looks like the low point is where I've got the, or is it the high point? I don't remember. There's my 40. And try to hit the 0. There's my 0. And that's about, yeah, I'll just turn this thing by hand here. Alright, looks like it's 40, which is coming out. This is the side closest to me, right at the screw, and at the low end I got the shim in the right place. I just don't have enough of them. Anyway, this is good enough, I think, for what I'm doing at the moment. I'll have to figure out some way of getting that thing over there centered. and I'm not really sure. The shaft itself may not be exactly centered in that. So checking this outside, I don't know how good that is, but anyway, it's a lot better than it was, and I'll go on to trying some cuts here and see how it works. Alright, I got an 1.25 inch piece running at medium speed. I'm in my low range, my highest gear, so this is my highest low speed. I just touched off. So what I'm going to do, I'm going to dial in 15 thousandths here and see how it takes that cut. Starting to pull the motor down, slip the belts, but it's taking a 15 thousandths cut pretty easily. A little chatter, that's what that noise is. And it looks like it was holding really good there. I'm not making a line when I back it out, and if it wasn't cutting right, that's what would happen. Alright, we're going to try another 5. Here's 10 thousandths, same feed and speed. Yeah, 10 thousandths. It's taking extremely easy. When it hits this next piece, that's going to be like 30 thousandths. Yeah, it's still pulling it. The belt is probably slipping. Yep. Belt started slipping and kicked itself off. But I can still see some kind of a repeating pattern in the finish across there. I thought it was because of this going fast and slow. I don't know. But at any rate, looks like I let it go into my stop again, and that's what locked it up. See, I shouldn't have let it go that far. Now I've got the feed reversed here. You say that's the fastest slow speed right there. Looks like it's cutting pretty good. I don't really see any patterns in it, but it looks like it's cutting good and the screws pulling good, and this is transmitting power properly. It's all good and tight, and now I'm going to try the slow speed and see what I can do here is making this a little shinier finish. I'm just going to dial in, well, I don't know, my gibs are not tight here. I'll do it with this one. I'm going to give it 10 thousandths more. Yeah, wrong way. Gotta reverse my gears here. That'll be feeding in. At a very slow speed, so this is going to give me my finest cut. It should look pretty nice. I dialed some out. That noise is chatter, and that's because it's sticking so far out of the end of the lathe. Okay, I drilled this on the end. We're going to just take it in. We get a 0, and I'll just feed it in here with a cross slide. And we're just going to put it in now and try to clean this up. It had a lot of chatter in it. A very rough surface. So now with it held securely in the stuff's falling off over there. forward, it'll get a heavier and heavier cut. Okay, I don't want to go too far because I'll interfere with the thing down here. I'm going to try a 3/1000. It's a very slow feed. Still got some kind of a pattern in there. Let me see if I can catch it. There is don't know what that pattern is. Anyway, that's my slowest speed. That's going to be my finest cut. And I can tell you right now, I don't like it. Might get something with a let me change a little different tool. This one's not known for making a good finish. This one's actually just a threading tool. I'll go in here until I make contact. And we'll just put on my feet end. See what a sharp pointed tool does. It looks like it's sort of removing the old marks, but it's putting new ones in. I'm trying to hear the motor pull down there. I don't know what's going on. Let's use this same tool, cut it deeper. See how it loads up. And it's loading up and cutting good. Anyway, that's a better finish, but I still can see those lines in it, which means that something's going on here. Still don't know what it is. I don't think tool bits are going to change it. I'm going to put something else on, but I'm pretty sure that we'll have the same problem here. Well, I got a tool bit now that I know will produce a good finish. I didn't check the center, but we're going to see what it does here. Yeah, it's taking off a nice fine little skinny chip. Looks like I'm still have that same ringed pattern. Looks like it's going away to a large degree. We're just going to take it back here. I'm going to put another 5/1000 in it on the cross slide. That would be 2.5 per side. Yeah, it's taking a very nice fine chip off of there. I can hear something going on. Kind of speeds up, slows down. I don't know if it's gears inside of this. I got gears here. Whoa, I'm just about to let it go here. Alright, this time I'm going to take off 0.10 on a cross slide. See how that goes. Not even touching it. I'll run it until it touches. Take it back. I'll put another 10 in. That's pulling off a little better chip. Looks like it's taken most of that pattern out. I can still see it in there a little bit. take it back, do a spring pass. This shouldn't take hardly anything off. I don't know if you guys can see this. I tend to hold this where the bolt's in the way. But yeah, it's taken off just a little bit more this time. And it's put back that same pattern into the finished surface. Don't know exactly what's causing that. Might take me a while to figure it out, but it's definitely got some kind of a pattern in there. And I don't really think that it's the feed of this thing. I think what's happening is that somehow the speed of the thing is setting up some harmonics with the I'm going to put it on high speed and see what happens. Alright, high speed. I'm going to put another 10 in here. Engage. Yeah, it's... You can see it. You can hear the motor pulling down. Pull down. Take a spring pass, see if that cleans it up or makes it worse. I don't know exactly what's going on here. Anyway, this is a problem for another day. But for right now, this big joint is in here, and you know, there's not much slack or anything in it. What's that? I'm just wondering if this is slipping on that shaft. You know, it looks like it is. No, it couldn't be. No, it can. It's impossible. That's a double D shaft. It can't move at all. That's just all of the slack that's in the gearbox, which is not much. You know, there's 4 or 5 sets of gears plus those, so that's really not bad. So that's a success. Now I got to figure out what's happening up here. Could be because this motor here is not really stable. I had to change it when I changed the gears, but adjusting this keeps the motor from bouncing, which sets up some harmonics in the table, and somehow it all transfers into the work here in a regular pattern. You can see it's a harmonic of something there. Anyway, that finishes the video of our new improved transmission joint, and clean up and reinstalling and milling off this thing so it holds good bolts. I put a 7/16 bolts in this one, and it all looks like it's shifting good. This is really a problem. I'll have to figure that out, but can't have a lathe cutting crooked like that. Here's one final note on the chapter. Same tool, same setup. I'm going to take off about 5/1000 here. It's feeding away from the head, and it's making a perfectly good cut. Every once in a while you can see it jogs a little. I just turned it in with my hand. But see, there's a rough pass, and it's turning a real nice finish. there's no pattern of waviness in it with it turning in this direction, which is counterclockwise. So turning towards the headstock gives me a bumpy pattern, and turning away from it gives me a good pattern. So this is turning counterclockwise. So when this thing is turning counterclockwise, it's all perfectly tight or something, and when it's turning clockwise, maybe it's not. So this might have something to do with the slack in this end here, or this bearing is letting the shaft kind of walk back and forth as it's cutting. I wouldn't think that would be the case, but it's cutting good in one direction and not good in the other direction.